Hello viewers, good morning. So in this video I am going to basically explain about the different types of drawings. So basically which we submit to the client. So when they are going to build their dream house. Okay. So this video is basically suitable for anyone who are there. So even if they don't have any knowledge on the civil engineering as well, it is fine. So basically it will be helpful for them if they are going to build their house. So they'll be getting idea about the different aspects. And again, for the civil engineers or structural engineers who want to improve their knowledge, so basically you can watch this video. So apart from that, so I'll be focusing on all the drawings basically in our training program, so which we are going to cover up. Okay, so first drawing, so which we are going to do is the architectural plan. So basically once we get the requirements from the clients, so based on what they want to accommodate in the site, what they are going to give, and we are going to draw a plan by using the CAD tool. Okay, so the here it's maybe it is looking very simple, and it's only we are going to draw just lines and keep the furniture so on. But however, the key aspects here lies is that what is the minimum dimensions of the room which we need to keep. Okay, so even if we are going to keep a dimension, minimum dimension less than like 3 inch lesser or 4 inch lesser, so then it is going to become so critical. So when we are going to occupy that flat. So simply by, if you are going to see this drawing, and if you see we have placed a different furniture. So simply keeping the furniture, maybe you could see that some people will be keeping the furniture and you may see very big hall. Okay, so basically that is wrong. So basically when we are going to keep the furniture in the different areas of the home as well, so we need to basically check in what is actual size of the dimensions. Maybe it is sofa, or it is cot, or it is some a stove, or the fridge or washing machine. So what is the actual size it is actually present in the market? Maybe for example, if you take as a TV, so you're gonna make a TV unit for your hall. So maybe people will be interested to have a 55-inch TV or 65-inch TV or 75-inch TV. So even that we need to plan it properly. Okay, so basically the role of the architect. So well, he is going to plan the houses to see that we are properly giving the minimum and maximum dimensions of the room. Okay, properly we are keeping the proper sizes of the furniture. Okay, and properly we are positioning the windows at the proper location. Okay, and as well as if people are interested, we are following the proper Vastu. And apart from that, we also need to follow the building bylaws. So in which country we are going to construct the building. Okay. And as well as the local rules as well, we need to take it into consideration. Okay. So this is a 2D architectural plan for a 2 BHK house on a 30 by 40 site. Okay. Now let me take you to the next drawing. So basically, after this drawing is planned, so here ends the role of the architects. So going forward, so apart from the 3D elevation which we are going to provide, so most of the things will be taken care by the civil draftsmen and the structural engineers. Okay, and even so, there are places like even the civil engineers they do the planning. Okay, okay. So next important drawing. So once a 2D plan is decided, right? So then we are gonna do the designing of the building in multiple tools or manually. So once the design is completed and all the structural members have been passed. So first drawing which we are going to submit to the client will be the column layout. So this column layout is going to have the boundaries of our site, which you can see this brown line is the boundary, and you are going to have the different column sizes. Okay, and you are also going to get the proper positions from the corners or from the boundaries of the site, how much position you need to place the column. So basically we are going to use these grids to properly position our columns. Okay, and one of the main important thing, so there is a misconception in the clients. So basically they'll be asking for the design for G plus 2, okay, ground floor and 2 floors building, and they'll construct the building, and then they'll go for like 2 more floors extra. So basically, that doesn't make sense, although many people are following it like that. Basic thing what is happening here is that one thing, the life expectancy of the structure is going to come down. Maybe because of you are overloading your structure. Maybe the house should come for like 50 years or 60 years, more than that. So it is gonna get damaged within some 30 years or 25 years. So people are seeing the immediate profit, but they're not thinking about the future. Okay, so the main thing is that the column sizes or the steel inside the column is going to be decided on the number of floors which we are going to build. Okay, so how much load is coming onto the column, what is the spacing of the column. So that these are the main aspects it is going to decide what is the size of the columns and the steel inside the column. Okay, and basically while we are going to design the building, so we need to consider the dead load, we need to consider the live load, we need to consider the wind loads for that location which we are constructing the building, and also the earthquake zone where the building is. And if you are going to have the snowfall area, we also need to consider the snow loads. And basically, I have seen most of the times, so the designers are neglecting the wind and earthquake loads. So because the combinations of loads, even when you are going to be in a zone 2 area of earthquake, although the earthquake is less in that side, so the Indian Standard Course is going to give us the loads which is properly apt to that zone 2. Zone 2 will be having lower earthquake loads, zone 3 will be having little bit more, zone 4 will be having more, and zone 5 will be having the highest. Okay, so basically this even the earthquake zones has to be considered irrespective of the place you are going to construct the building. And if it's like a multi-storied building, so mandatorily we need to consider these loads while we design the buildings. Okay, so this column layout, we are going to have the column sizes and its positioning from the boundaries of our site. Okay, so now let me move on to next set of drawing, footing layout. So next important thing is footing layout here. So basically in this drawing we are gonna show the sizes of the footings. You can see I'm having a combined footing 1, I'm having a combined footing 2, I'm having footing 1. Okay, we are going to have the sizes of these footings. And again, from our boundary, the spacings. And one important thing what we need to remember here is that it's not simply we are going to put the footing size of our choice. Again, it is going to be dependent on mainly couple of factors. So first thing is, so the size of the footing is going to be decided based on the soil bearing capacity of the soil. So basically what is the bearing capacity of the soil? So based on that, and also how much load we are going to get from the columns, based on that we are going to decide the size of the footing. And the depth of the footing where we need to construct, basically at different depths we will be having different bearing capacity of soil. So ideally in normal size we go at least up to some 6 feet of depth, so that at least we will be getting like 150 to 180 kilonewton per meter square of the bearing capacity. Okay, and again, so this is where people tend to not invest money. But if you think that the soil is not hard, it's better to we need to do the we need to send the soil samples to the geotechnical lab and we need to check the soil strength. Okay, sometimes when we are going to have loose soils and we are having a multi story building being built up, we may require to go for the pile foundations as well. Okay, and then again, it's not based on the loads which you are going to get from the columns, the reinforcement in the footings as well be decided. Okay, so the main important thing when we are gonna design is, so we need to decide the grade of concrete, whether we are giving it as M25 or M30, and as well as the grade of steel which we are going to give. So whether it's 500 or 550D. So basically one thing which every client needs to remember is that, so when we are going to give the drawings, we'll be giving you the recommendations. So besides these drawings, what we need to follow, right? So we will be giving you the grade of steel, what you people need to use, and grade of concrete, what you need to use. And even in the grade of steel, we will be specifically mentioning it as 500D or 550D. So when you're going to purchase the steel or the rebar from the shop, so if you are not going to mention them, you want 550 grade steel D, 550D, it's deformation. So D for deformation. So basically, as strength of the steel increases, the brittleness decreases. To maintain that flexibility there, so to make the brittle structure to take more loads, and so that it will have more elongation capacity, so more deformation. So basically we prefer even in the designs, we in the design drawings as well we mentioned 550D grade of steel. Okay, so if you are going to construct your own building and if the designer is going to give 550D FE 550D grade of steel, so please let the shop owner know that if you are not going to ask them that specifically 550D, he's not going to use it. Even if you are going to give for a contractor, if you are not going to mention him 550D, although he knows, he won't be taking up because there is a slight variation in the price of the steel for 550 and 550D on any company steel. Okay. Now let me go on to next set of drawing. Footing detailing. Okay. So earlier we have seen the footing layout and we have seen the footing sizes. So here it's a sample which it is showing how a combined footing looks. And here you're going to see the info of footing type, the dimensions, what would be the reinforcement in the long bar spacing, short bar spacing. Okay, so you're going to see the complete info about the detailing of the footings. Okay, again this is going to be dependent on the loads which we are going to get from the columns. Okay, so now let me move on to next set of drawing, column detailing. Okay, now we are going to have like a different types of columns, right? Sorry, different sizes of columns. Okay, now if you see, I have give you multiple combinations. See, sometimes what happens is that the draftsman will be relaxed and he want to complete the work very faster. So although we can try to give multiple combinations, so what happens is that sometimes it will be difficult for the bar bender to read through the drawings. If you are going to have multiple times, it will take for him to do it. Okay, and even for the draftsman, if he is going to have multiple combinations, he need to create detailing for each and every column. So that's why if you see like most of the people, sometimes they'll be only giving less combination of columns. Maybe they're not doing the optimization, and they are, although we are gonna getting like 10 to 12% deviation in the rebar sizes in the columns, maybe they'll combine it and they'll be giving the higher sizes. Okay, so the main important point to see in the column detailing is different column sizes, and again how are these spacing of the stirrups and the dia of the stirrups. Okay, and the number of bars and where we are doing the curtailing, and we will also be giving you the structural information that where you need to do the curtailing, how much should be the lapping length, so on details. Okay, however here I have not mentioned the specifications, all the drawings I just want to zoom in, so that's why I'm only showing the drawings here. But however for every drawing we'll be giving the architectural instructions or the structural instructions. Okay, now let me move on to the next drawing. Okay, plinth beam layout and detailing. So so once column layout is done, footing layout is done, and footing detailing is done, we may require to give the plinth. So at the ground level we need to give the beam layout. Okay, and we need to give the beam sizes, and again some however in the plinth we are going to get the minimum reinforcement. That's why in the same drawing I am providing the beam detailing as well. Okay, so you can see the different plinth beam sizes. Okay, spacing between the beams. Okay, and you can also see the detailing of the beams. Okay, now let me move on to next drawing, slab layout. Okay, so this is important apart from the ground floor. So every floor we are going to have a slab. So here we are gonna show up the sizes of this slab, thickness of this slab, right? And we are going to show the proper column positioning. We are gonna show the beam names. Okay, so this in this slab layout we are gonna get the proper shuttering layout. Okay, so now let me go on to next set of drawing. So then we are going to see the slab detailing. So it is going to give you the what is the size of the bars you need to use, what is the curtailment length. So this is a typical detailing of the slab. Okay, and then again you can see that multiple combinations of bars is used. Here you could see like 8 bar being used at 5 inch center to center. Okay, for the distribution reinforcement or the main reinforcement. Again here you can see like 8 bars, again it is at 10 inch center to center, so it's a distribution bar, and 5 inch center to center are the main bars. And again, it's not like that every time I'll be going with a 8 bars with 5 inch, 6 inch. Again, it depends on the size of the slab. If it's gonna be a commercial building, I may go with 7 inch slab, 8 inch slab, and we'll also going with 10 bars. It could be like two-legged or three-legged chairs. Okay. So now then, let me go on to next set of drawing. Beam detailing. So basically, in the plinth, we may be having only just like one or two combinations of detailing for the beams. But however, when you are going for the first floor or the second floor, you are having multiple combinations of beams and its detailing. You could say I have given multiple combinations so that I can optimize the usage of steel. And even if here you can see the ties, I have using different combination based on the shear capacity, which we are going to get from the design. Okay. And maybe there are like when we are going to have like commercial buildings, so we may get this type of beam detailing as well we will be giving. So where we will be giving a long section as well to give the complete clear cut information. So where we need to have more steel, where we need to have less steel, where we need to have like when we are having more negative moment at the top bars where we need to give extra. So even based on the structure, either we can give individual drawing or we can give the long section drawings. Okay, so then let me go on to next set of drawing, staircase detailing. So the basic important thing is that people tend to take the staircase detailing as light, but however, when we are not properly going to do the staircase detailing, so when horizontal loads comes up, heavy horizontal loads comes due to earthquake or wind loads. So at the time, this junction of staircase is become a critical and it's is going to have a severe impact on the structure. Okay, so even we need to properly follow the proper norms and properly we need to take the depth when we are going to build the staircase from the ground floor. People they don't take the steel bars into depth and directly they may sometimes take at the floor level as well. So that is not a proper recommendation to take it because unless even for the staircase we need to have a proper strength at the base. Okay, although we may not require to go like 6 feet, at least we may require to go for like 1.5 feet or 2 feet so that we'll be getting a proper strength and proper tightening will happen and we are going to get the grip when the loads transfer as well because even in the ground floor, right, so we need to transfer the part of this staircase load to the footing of the staircase, right? So this as well should be properly done. Okay, so now last but not least, let me go to the final drawing, working drawing. So now initially we have seen the architectural plan, then we have seen all types of structural drawings. So when you are going to basically construct the walls in each floor, basically we may require to have a proper spacing information. So this working drawing is going to give you the proper room dimensions. And if you are going to have the columns, what is the size we are having from that to window, what is the spacing we are having. So like this, so different rooms and the spacings, window spacing, everything we are going to get a clear dimensions. So basic thing now, if you people are not going to have a proper drawing. So even when we are going to have a proper working drawing, people will do the mistakes. If you are not going to have a proper drawing, so the contractor who is building the house or the masonry who is building the walls, so he may construct this wall. Instead of taking 3 feet, he took like 2 feet. He has done a mistake. So now at that time you need to demolish that wall and you need to reconstruct it. Or if you are not interested to demolishing it, you need to when you are going to basically occupy the flat, so then you will be facing difficulties in using the room whose minimum dimension is not being kept. So if it is you are going to have a balcony with 3 feet, you can better utilize it. You are going to get it as 2 feet, then what you can do? And it is fine for balcony, you will manage, you will stand, you may not put a chair or something. What happens if he is building a toilet with 1 feet lesser dimension, right? So there are multiple practical challenges. So if you are not going to have even with the proper drawings people tend to make a mistake. I don't tell that if you are going to have a drawings that building is going to be perfect, but proper supervision from an engineer would be required or even without an engineer, the owner of the house, so You need to understand that why we are giving these structural detailing drawings, why we are giving the size of the bars, right? We are going to give each and every information clearly in the instructions. So even if the owner is going to go through those instructions, so basically if the contractor is going to do the mistake, we can rectify it earlier itself. Okay. So basically, whoever the engineers, whoever are interested in our program, I guess you can go through the different tools we are going to cover in our building the planning and designing program. And these are the some of most of the drawings I have shown. So whoever have joining our program, so they will be getting the intermediate proficiency in creating all these drawings. So I'm not going to limit the students to learn the architectural planning and do that designing and it is done, but they are going to prepare this footing layout, column layout, footing detailing, all structural memorial detailing, even the shear wall detailing, everything. Okay. So if clients are interested to take services from us, you can go through our website. So there you can get the detailed cost and the services which we are offering. And even for the students who want to take training with us, you can go to our website. There you can see the different information about our course, the fees structure, fees details, number of people. So we are limiting maximum number of students per batch to only 9, so that we can have a proper communication and even the students can get the maximum benefit. Okay. And we are again having different programs as well. You can reach out to me on WhatsApp or you can give me a call if you want to get more idea about the services which you are offering and also the courses which you are offering. Okay. Thank you everyone for watching the video. Have a nice day.